Hey, fellow mathers. Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over 6K worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians. Welcome to the podcast where math is figure-outable. I'm Pam.
And I'm Kim.
And you found a place where math is not about memorizing and mimicking, waiting to be told or shown what to do, but it's about making sense of problems, noticing patterns, and reasoning using mathematical relationships. We can mentor students to think and reason like mathematicians. Not only are algorithms not particularly helpful in teaching mathematics, but rotely repeating steps actually keep students from being the mathematicians they can be.
So this week we are going to do, well, actually, Pam, it's Valentine's Day, right? So we're going to tackle another problem string that we love to do.
We love
or a
Valentine's
strategy that we love, that we now both love.
Now.
So we're going to do a problem string today to tackle a very cool strategy for addition and subtraction.
And the reason we're laughing is because we'll tell you in a hot minute about the fact that maybe it wasn't a favorite to begin with, and why, and why we like it now. Cool. So I remember where I was standing. I can picture the room. I know who was in the room. I was doing professional learning here in the state of Texas. They had come and asked me to do 8 days of numeracy training for K-12 leaders across the state. And it was fantastic. We did 4 days right in a row. We were downtown Austin. We were in a hotel, ballroom kind of space, and we had way too many leaders in the room, but they were amazing. And we did 4 days in a row, and then we let some time pass, and then we did another 4 days, and it was a training of trainers kind of a thing, and phenomenal experience. I had such a good time. We had so many really, really wonderful leaders in the state of Texas at that point. And I remember near the beginning of the workshop, we were doing some subtraction. It might have been addition. I don't know. It doesn't matter. It was addition or subtraction. And I had a particular strategy in mind. And I gave a problem like, so I don't remember exactly the problem, but I gave a problem like 63 minus 28. And I was looking, we're in the, oh my word, I'm sitting at my movable desk and it's going up on me. I reached for my pen and all of a sudden I hit them. I'm sorry. I had to. Okay, here we go. Moving on. Live recording as we go. So I'll never forget. I was looking for 63 minus 28 in the midst of that problem string. I don't remember exactly what strategy, because with that problem, I could have been trying to nudge a couple different strategies, but let's just say I was going for the over strategy. So I might have had 63 minus 30 as a helper problem. And then I gave 63 minus 28. And I'm expecting everybody to think about 63 minus 30. And then how would you adjust to get 63 minus 28? And there was a physics teacher who was, she was a leader, but she was like more physics than math. You know how science people kind of identify sometimes as like, I'm a physics. And she was wonderful. I'll never forget. She had this look on her face and I was like, oh, cool. Like she's really, I've taught her something, whatever. And I called on her and I said, hey, what are you thinking about? And she goes, oh, do you want to know? I was like, yeah. Like, tell me what strategy you're thinking about. Now I've learned if I want the over strategy, in that moment, I should have said, did anybody use the problem before? If that's the one I want to celebrate. But in this moment, I didn't know that move. And so I'm kind of calling on anybody cold, but I was so excited. She had this look. I was like, oh, I want to hear what you're thinking about. And she said, I cannot just see factors. And I said, I'm sorry, what? Are you in the room with us right here? Right? Like, you're off somewhere. You're thinking about something else. She goes, no, like I can't, I see sevens. And I was like, what? 63 minus 28. She goes, yeah, I see 9 sevens and I see 4 sevens and I just can't stop. I can't stop seeing that. I see 9 sevens is 63 and 4 sevens, 28. And it's just like screaming at me that therefore 9 sevens minus 4 sevens would be 5 sevens. And I know that's 35. And my brain is just there. And I looked at her, I was like, what? I had never, I was like, that's what your brain did? Like, how did your brain go there? And she goes, I don't know. It just did. Like the factors are just screaming at me. Y'all, I don't know how long I stood there with my mouth open. I was like, does anybody else think that way? Now, honestly, I think when I said that, there were a couple of hands in the maybe 50 or 60 people that we had. It was way too many people for one training. So not very many people, but most people were intrigued. Most people were like, that's interesting. How often does that happen? Is that a thing? Do people actually do that? Well, y'all, I'll tell you what, the more I throw problems like that out, the more I find that people, if they are thinking multiplicatively, if they have built relationships in their brains to think multiplicatively, factors can pop out at the most opportune times. So let's do a problem string, Kim, to see if we can kind of build that strategy in our listeners a little bit. Here we go. Okay. All right, first problem. Kim, what if I were to ask you a problem like 88 plus 72? 88 plus 72. Tell us what you're thinking about.
So 88 and 72 have 8s in common. So 88.
How so?
88 is 11 eighths. So I just wrote down 11 parentheses 8, 11 eighths.
Oh, okay.
Plus 72 is 9 eighths.
Uh-huh.
And so 11 eighths plus 9 eighths is 20 eighths, which is really nice because that is 160.
How do you know 28 is 160?
2 times 8 is 16, times 10 is 160.
Nice. So you could look at an addition problem like 88 plus 72 and use, and factors popped out for you, and all of a sudden you have this nice 20. Now, if you would have gotten 19 eighths, I wonder if you might have gone back to addition and done like an over strategy or something, or even for these numbers, splitting by place value, because there's that nice 10 sticking in there. So it's not like this has to be the strategy that you do if factors pop out at you, but it could be one that you can consider. Next problem. Maybe I'll pause a little bit longer before I let you answer it. So, or listeners, solve the problem before you maybe hear what we're doing. You know, give yourself a chance to see if factors can pop for you. So, Kim, how about 81 minus 36?
81 minus 36. So I'm looking for what they have in common. And I'm thinking that there's some 9s there. So 81 is 9 9s. And 36 is 4 9s. So 9 9s minus 4 9s is 5 9s, which is 45.
Nice. And often kids know their 5s. So that's a pretty 5 9s once you get there. I mean, I know you know. But often kids, if they're going to know facts, they'll know their 5s. Mm-hmm. So that's not too bad to land up with 5 times 9. Cool. All right, next problem. How about?
And I'm going to tell you real quick that I actually like that strategy more than I like really any of the strategies that I would use for subtraction of that problem.
Oh, that's interesting.
Yeah.
So I might be tempted to shift everything up 4 and have 85 minus 40, which is also 45. Which is good because it should be. But you're like, no, I actually like the factors.
For that one, I really do like that strategy.
Nice. All right, how about 77 plus 44?
There's some 11s there. So 77 is 7 11s and 44 is 4 11s. So then I have 11 11s, which I know is 121.
And if a kid didn't know 11 11s, then
they might do 10 11s plus one more 11. So 110 plus 11.
Yeah, I like it. Or they could even back up and just do an addition strategy.
Sure.
So our goal isn't to pigeonhole anybody into any one strategy.
Right.
Our goal is to own lots of relationships, so strategies become natural inclinations.
Yeah.
I'll never forget the day, Kim, when you said to me, I look at numbers and I let things pop and I go, how about this? How about that? Oh, actually, the middle one. Like, you consider different things you can do, and then you choose the one that on that day sort of slides the easiest. And I'm working on my definition of fluency, but that's my definition of fluency. My definition of fluency is looking at the numbers, letting what naturally pops, that intuition tells you, and then going with the one that, like considering all the things that pop, not all, but enough of the things that pop, and then going with the one that slides the best that day. Yeah, I know that's not a very technical definition, but I'm working on it. What it's not is that students go, oh, for this problem, I do this procedure. Step. Right. Right. That's not fluent. Okay, ready? Next. 64 minus 48.
So they have 8s in common. So 64 is 8 eighths. And 48 is 6 eighths. So 8 eighths minus 6 eighths is just 2 eighths, which is 16.
I wonder, listeners, as you're hearing these problems, if because we've kind of got you in factor mode, that maybe you're like, maybe it's starting to ping a little bit more. Maybe it's starting to like, you're like, because and that is a real neurological thing, that once we kind of get you situated and factors are kind of the thing that we're talking about, then they might pop a little bit more readily. All right, let's try another one. How about 144 plus 96?
Cooper would love this one because he loves 12s. So 144 is 12 12s and 96 is 8 12s. So 12 12s plus 8 12s is just 20 12s, which is 240.
Because 2 12s is 24 times 10. Yeah. Now, I'm going to be really honest. 96, I had to think about. I did not have a lot of experience with 12s. It is still the one that I have to go, what do I know? Let's see, I know 7. For some reason, I know 7 times 12. I think I actually work off of 6 times 12. I know 6 times 12 well. And so 7 times 12 is pretty. And so I'm like, so 96. So that's got to be 8 times 12.
That would probably be, go ahead. Sorry.
96 does not pop for me as a 12. However, because the 144 is sitting there, 144 is so 12 squared to me. That one is just ingrained. Then I'm kind of asking myself, is there a 12 and 90? Oh, there is a 12 and 96.
Yep.
Yeah. What were you
I would say that's probably would be true for me until about a year ago, that I don't own 12s as well as some of the other ones. But because of Cooper, he so loves 12s that we talk about them probably far more often than we should in this house.
So since you've been messing with 12s, 12s are on the top of your head more and more. And so now it's a relationship that you can draw on. Yeah, nice. Do you know what else is funny about, I'll tell that some other time. Okay. So to end this problem string, I'm going to ask the question, and we're not actually going to answer it on the problem string, but I'm going to ask a question that we just put out on Math Strat Chat. So we've been doing, might have been 3 or 4 weeks ago, we've been doing a series of problem strings to try to build this strategy, this idea that to add or subtract, I can see if there are common factors involved. And if factors pop, then I can use those factors to think about adding or subtracting. And so one of the last problems that we posted was 25.6 subtract 12.8. And now that I've done that, now that we've done this problem string today, and we've been talking about this idea of factor to add or subtract, we're gonna leave that problem, listeners, and maybe you could go check out Math Strat Chat. You can search for hashtag Math Strat Chat and see what you can do with 25.6 minus 12.8, and go see what other people have done for that problem.
Yeah. So I remember being in the hotel when you, I don't remember the details exactly, but I feel like what happened was this person shared this strategy, and you were like, that's amazing. I want to come back and think about it. And if I'm remembering it correctly, you came back and you were like, I need to write a problem string for that. Or
yeah.
Typically your response, right? When somebody shares something cool.
Oh yeah, because I was so fascinated that I wanted
Yeah.
my brain to do that. And so
Yeah.
a way I do that is I try to write a problem string to teach other people to do it, and that helps gets it in my brain.
Yeah.
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 So what I do remember is that,
Is that one of those
you
moments when you were like, "Oh, Pam."
I don't know. I don't remember, but I will say that I remember that I was there when you were tinkering with it, and then there when you did a problem string either that day or some other time. And I remember we've had this conversation that I remember being like, yeah, I mean, I get it, but I'm not all that impressed. I remember thinking like it's cool, but nobody's going to do that. Like, why would you
Mm.
ever why would you ever go to factors and thinking about multiplicative relationships to solve a really straightforward addition or subtraction problem? And I'll tell you what, I wasn't really convinced that people would actually do it. And it really, you said that I've run into this and whatever, and I guess I kind of believed you, but not really. And it was never one that I really used. But when you started putting out the math strat chat problems that had factor to add or factor to
just
subtract
recently.
recently,
Yep.
right?
Yep.
You
Yep.
know, when math strat chat comes out, I hold my phone in front of my children's faces and ask what they would do. And Luke, my older son, looked at the problem and he said an answer. And I said, "How do you know?" And he used factor to add or factors, whatever was addition,
Whatever it
subtraction.
was, he totally did it.
And he
Oh,
did it,
go
and I was like, "What?"
Luke.
Because we've never talked about it before, and he just uses those relationships. And I remember texting you, and I'm like, "All right, fine, I get." Like, okay, people do.
Oh, ye of little faith. Way to go, Luke. Oh, I love that kid. Good. You know, it's interesting because at the same time period, my particular son was, I don't even remember why, but he said to me, "Wait, what's that strategy?" And I said, "Well, you know, like," and I gave him the problem 81 minus 27. I said, "So, you know, if 81 minus 27," and he goes, "Oh, well, I can clearly see 9 nines minus 3 nines. So it would be 6 nines." And then he goes, "But I don't really know 6 nines. So I wouldn't do that. I would just do minus 30 plus 3. I was like, but that's an example. And that's my oldest son, by the way, the one that got me into all this. That's an example of someone who owns relationships, who says, oh, okay, I could do that thing. So he had never thought about factor to add or factor to subtract. But once I raised it, he goes, "Oh yeah, I could totally see the 9s in there." But that would give me 6 times 9, which I don't know. So I probably would have just done. It's exactly what you said, Kim. People with relationships go, "I could do this, I could do that, I could." I'm going to go with the one that today slides the most easily. That my intuition is just like, vroom.
Yeah. And nice. I think the extra piece of that, Pam, is that it's perfectly okay to get started down a strategy, realize that where it's going to leave you is something that you don't want to mess with, or it doesn't make, your life easier. And so then you back out of it. And I don't know that, I think we've said it before on the podcast, but it is not a magic, like, oh, what do I want to do? Like, pick the right thing. Sometimes you try some strategies and you go, I'm going to back
Not
out
today.
and I'm going to do something different. Yeah,
absolutely. And that's mathematical behavior.
Yeah, absolutely.
And hopefully it can free everybody up. And maybe one other thing that we'll mention about this is a really cool strategy, but you'll notice that it's not in our major strategies ebook.
Yeah.
Why is it, Pam, if it's so cool? It's a fun, interesting, great strategy to use. And I would use it. I would do problem strings like this with students who you're trying to get them to think and reason either additively, and you've got some kids that are already reasoning multiplicatively. And so throw in some numbers that have common factors, and that can keep those kids they're already reasoning well additively. They can keep them going. It can like, oh, they have something to think about. Or use it with kids who you want to get, that you want to work on multiplicative reasoning. You want to work on sort of some single digit facts with multiplication, but you want to do it in a little bit of a different context. We could do it here where you're hoping those factors begin to pop a little bit more. Consider if you just a problem string like we just did in this podcast, right before you do some things like adding or subtracting fractions, where you want denominators to pop as with common factors, this could be something that could kind of get that warmed up. That now those numbers are popping with common factors, and now you're like, oh, so if I'm looking at common denominators, bam, I've got these common factors popping out. That could be sort of helpful there. So it's not a major strategy, but it is a fun relationship that we can play with if our goal is to get kids to think and reason like mathematicians.
Yeah. It reminds me a little bit of how much we love the swapping strategy, which is not something that is on our e-booklet either, but it's a really cool strategy. And when the numbers are there, they're primed for that strategy. Why not use it? It's cool and fun to try new things.
Yeah, and maybe I'll just clarify one other thing. So why is it not a major strategy? The major strategies that I've chosen because those are the ones kids need to own. Mm-hmm. Those are the ones we need to work on so that they can solve any problem that's reasonable to solve out of calculator.
Yeah.
So that's why those are the major ones. We need to work on those. But there are other fun ones that we can also build in kids toward the aim of creating them as mathematicians. That's the difference between if we've labeled something as a major one versus not. And maybe we can get into that more in a different podcast.
Yeah, and maybe if people don't know about that, they're new listeners and they don't know what we're talking about when we're talking about the major strategies.
Oh yeah, we should probably
throw that link in the show notes as well.
Absolutely, and it's mathisfigureoutable.com/big. So because it's a big free ebook that you can get, mathisfigureoutable.com/big. You can download that free ebook if you haven't already. Check it out where you can find those major strategies. Hey y'all, thanks for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figureoutable. Thank you for listening and making math more figureoutable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more figureoutable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.